Hi, I'm Quincas and I'm a synth DIY guy, and today I have the pleasure of presenting to you the official video manual for the Syntrx II by Erika Synths. The Syntrx is the culmination of our analog sound design circuits, two perfectly stable main oscillators, with Waveshapers, a versatile multimode filter, supercharged external instrument inputs with envelope follower, a unique great sounding ring modulator, a recordable joystick, and built-in piano roll sequencer, all ranged around our signature matrix mixer, topped off with powerful effects on our new DSP platform, introducing the Syntrx II, a new dark horse for experimental sonic rides. So this is what it says on the manual, the physical manual. I'm actually looking at it right here on an iPad. That's a basic description of what the Syntrx II is and does. Included with the box, you get the synthesizer, the universal 12-volt DC wall wart adapter, a user manual, physical user manual, and 10 patch notes stencils. The Syntrx II, like most synthesizers built around the patch matrix, is somewhat similar to a modular synthesizer. Here you can modulate any available module with another, and possible connections are almost limitless. The mixer splitter matrix allows for mixing up to 16 signals to one output and vice versa, because all inputs and outputs are buffered, splitting one signal to 16 destinations, right? And I made a little cheat sheet here for it because there are quite a few button combinations and tricks to find the more advanced features, but we will start with simple stuff at first. So here's how you navigate the matrix, right? You can navigate it by simply turning these two encoders etch-a-sketch style, okay? And the way you make a connection, these encoders are buttons as well. So if you push the right one, right there, let's turn that down a little bit, too loud. Basically what I've done just now is patched the square wave from oscillator 1 to channel 1 output, right? Let's center that output, right? There's panning for both outputs, there's panning and level, so you can tailor your output from full stereo to full mono and anything in between. Right now I used the right encoder button to make that connection. I can press it again and interrupt that connection. Now if I use the left button, you get levels. So you get full, this is a little attenuated, this is a little bit more attenuated, and this is off again. Right, so you have 4 levels: off, fully on, 70%, 30%, and then off again. Okay, so this is especially cool because you can do some of your attenuation on the matrix itself, even though you do have a number of attenuators distributed throughout the panel as well, such as the noise over here or the sample and hold level. There are many ways to control the levels within your patching. Okay, so there's also another way, which is if you hold shift, you can use the joystick to navigate on the patch matrix. See? You can use them in conjunction too. So let's say you want to come all the way over here, you would be a little longer than to just hit shift and go there with the joystick, and then you can fine-tune the position with the encoders here, right? Let's start by making a simple patch here. Why don't we send our oscillator to the filter, right? So we're going to send, here are the signal inputs and the control inputs, and here are the treatments and sources, right? So the oscillator 1 square wave is a source, so we're sending it to the filter directly. Okay, now we still don't hear anything because there's nothing patched to the outputs. Now if I were to patch that filter to output here, we now we have a level control here for the filter. There's a level control for the square wave as well, oscillator 1, right? So, and the filter has resonance, of course. Sounds very nice. The Oscillator one has an octave switch, and there's a shape knob as well. So right now, this Oscillator 1 shape switch allows me to shape either the sine or the pulse width, or both of them at the same time, by using the shape destination in the control inputs over here. Right, so you have oscillator shape as one of the control inputs. So we'll leave it in the middle where it's nice and square. And here we have the high pass filter and the low pass filter, right? And they can either work separately with the CV, right? The matrix point here. Whatever you send to it can either only affect the high pass or only affect the low pass, or both together, which effectively turns it into a band pass filter, right? Because if I send modulation here now, it'll move both the knobs, both the frequencies together, and that way you'll be cutting lows and highs and basically working with a band pass filter, resonant band pass filter. So that's a very cool feature right there. Okay, now we can try the sine wave rather than the square wave, just so we can hear that wave shaping, right? So let's open up the filter, let that come all the way through. Sounds nice, right? Very cool shapes available from the sine wave here. And if I turn it off, even though the patch is made, you still don't hear anything because I've turned it all the way down. Now I can use both as well, and this way I can mix them together, right? How much sine wave do I want? How much square wave do I want? And what shape do I want for them? What the switch will affect will be the incoming CV via the matrix, right? So I have Oscillator 2 here is very similar to Oscillator 1. In fact, it's nearly identical. The difference being that instead of the sine wave, you have a saw wave over here. So why don't we listen to that? Let's get that Oscillator 2 in there. Let's turn down Oscillator 1. And here we have the pulse wave, right? And again, I can change the pulse width by affecting the shape here. And I also have the saw wave. The saw wave also changes shape. And you have another switch here, right, for Oscillator 2 shape CV control. Either pulse width modulation, saw shape modulation, right, with the incoming CV. Now what kind of CVs can I use? Right, there's also, by the way, an octave switch here. Both oscillators have it, and the fine tune, 2 octave fine tune here. Okay, we can turn these back up, and we're already getting quite a swarm of sounds here. Right, now Oscillator 3 is mainly intended to be used as an LFO. Right, it's simple. It's got square wave and triangle wave, right? And it shares an output with the sample and hold. Well, the square wave anyway shares an output with the sample and hold. So you have to choose that with this switch over here on the random section, right? So if you want this matrix output to reflect the square wave, you would put it on the up position, which is a square wave Oscillator 3, right? And there's a shape for that as well. Now this one we can assign perhaps to the shape, right? So let's take Oscillator 3 triangle wave, and we're going to take it to Oscillator shape. So that's actually going to go to both of them, and we can turn the levels all the way up already. Let's turn these down and only hear the saw wave. So this switch is a little bit different. The middle position, you get no modulation at all. See? Here's my square wave, and here's my saw wave, no modulation at all. If I put it on the right, I get saw wave shape modulation. Which is somewhat similar to a pulse width modulation, only applied to a saw wave, right? If I turn the saw wave down, put the square up, and I turn that to the switch towards the left, I get pulse width modulation now. And that gets added to or offset by the shape knob, right? And in the middle, you get no modulation at all. Whereas in the left side oscillator, oscillator number 1, the middle position affects both pulse width modulation and sine, and you can see that represented by the plus sign over here, whereas here it's just a little two-pointed arrow. Okay. And if I put it on sine only, then we only get shape modulation for the sine wave. Like that. If I shift it to pulse width, we only get pulse width modulation. And right there. Very cool. And here's the filter again. Remember, these are all going through the filter. Now this thing has a very cool envelope generator called Trapezoid. This is inspired completely by the trapezoidal envelope generator that was present in the machine that inspired this machine, the Synthi AKS, right? So here you can put it on position 10, which is manual, and then it'll only be triggered by either the button here, the gate sequence button, or an external gate from an external controller, such as a keyboard controller or a sequencer, right? But you can also have it in a position that makes it loop by using this knob right here. The trapezoid knob is the loudness of the CV coming out of the envelope generator, and signal is the built-in VCA here. So you can route a signal through the trapezoid VCA, and it'll be affected, the amplitude will be affected by the envelope, by the trapezoidal envelope. Okay, so let's create a patch using that, right? I'm going to empty out. You know what? Let's leave this patch existing as it is, because I want to actually show you something else that's very cool about this synth, is that the patch matrix being digital allows you to have memory to save it. And to save it is as easy as just clicking the save button, and then you can choose any point on the matrix to save it to, right? So I just saved it to point number 1, right? Over here, 1A. Okay, and you can have a little notebook where you write down what your patches are, names for the patches, etc. There is a mode where your patch save and recall actually show up as numbers over here with the matrix as a screen. But for now, as easy as this, I can just recall an empty patch here, right, and I have silence again. If I hit recall again, you see that 1A or A1 dot is lit. That means that there's a patch there, and I can click on it and recall it that easily, right? Okay, so now let's recall an empty patch again, and we're going to use the trapezoid. So what we're going to do is route the square wave of oscillator 1 over to the filter, and we'll route the filter to the trapezoid input. And that is envelope signal right here, number row 4, or is it column 4? I get row and columns confused. Alright, so we've got the oscillator going to the filter going to the envelope signal. This is a good opportunity to show you effects as well. So we're going to send the envelope signal to the effects input, and the effects output we're going to send to channel both 1 and 2 and the scope too, so we can see what's going on. Right? Put the scope into audio here. Well, that's a view meter, but there is a scope output here that's tied to the meter that you can send to actually see the waveforms on an oscilloscope if you like. Right? So right now the trapezoid is not engaging, so we're not hearing anything. But if I hit gate here, suddenly we hear a sound. See? I let go, and it's gonna decay according to a couple of things here. So you have the attack, you have how long you want it to stay on afterwards, after the attack, and then there's the decay, which is how long the sound will take to go back down. So if I put on to 0 and decay to 0 and attack to 0, you get this immediate kind of a sound. Now I have too much of the effects going on over here. Right now we have a reverb. There is no dry wet for the effect. So right now we're hearing the effects fully wet, right? So if we want to mix the effects, the way to do that is to actually route the envelope signal as well as the effects to the outputs, right? So we're mixing them, and then we can pan left and right here and have both outputs at the same volume. And now the level here, the effect level knob, will basically be our wet control, right? How wet do we want this to sound? So, right. Let's see. Yeah, that's what was happening. When we route something to the scope, it also goes to the input 1, which has an envelope follower and generates a gate, and that's what was keeping our trapezoid up. So there's, you know, there are little tips and tricks to know about this machine. Sometimes you might think something's faulty, but it really is just a matter of really learning the ins and outs here. So I'm glad I knew about this. Yeah, that's how, in fact, you route an internal sound to the envelope follower if you want to use it with an internal sound. You can also use it with something external like a guitar or bass or something like that. So if you don't, you can either remove the routing from scope here or just turn the level all the way down on input 1 here. And now we have our nice short envelope here. Let's turn down the effects for now, just a tiny bit. There you go. So now I have attack, on, and decay as short as they go. So basically it's just a gate, right? Now if I leave on longer, that does nothing at all when you're using an external gate, right? Be it the button here or a sequencer or a keyboard. Get a softer attack. There we go. Right? So now let's turn the off knob to another position other than manual, right? And that will allow us to cycle it. This is just on and off, right? This is how long is it on and how long is it off. I actually just finally understood these knobs. I've been using them for a while. But yeah, this is short on, right? Long off. And now we have a short on and short off. So we have this quick thing. Now we have a long on. So yeah, literally, this is what these two do. How long is the on gate and how long is the off gate. And if you put it in manual again, then you get just manual. It just waits for an external gate, right? Now the joystick here, we can use this for pitch right now. Why not, right? So the joystick is available in the matrix, the XY over here. So we can send that to pitch control of the oscillators. So we have oscillator frequencies 1, 2, and 3 here. So why don't we use vertical for 1 and horizontal for 2. Right, and now we only have one oscillator waveform going into the filter right now, so we might as well send another from another. So Oscillator 2 here going into the filter as well. So now we can hear both of them. And we hit control the pitch of one with our horizontal movements and the pitch of the other with vertical movements. I mispatched over here. We want this one on this side. So let's see. Very cool. Let's change the effects to a delay effect with longer time, a little more feedback, a little more level. And now we're getting into the familiar territory of experimental synthesis with this kind of synth, right? It's what the synthes were known for. By the way, you also have a level control for the joystick here. So this is like a range control. If you turn it all the way down, you get no change at all, right? Turn it all the way up, you get the full range of modulation, which depending on your use case might be excessive, so it's nice to have the attenuators right here. The LEDs of course reflect, so you have green for positive and red for negative on both axes. Now what's really cool about this joystick is the recording function. You can record your motion, your movement on it, just like the Eurorack module called Black Joystick 2. So let's do that. Let's record a cool little performance here for a few seconds. Right, and leave it on. Now, it didn't record the gate. So when I want to hear it, I have to hit the gate here. So this might be a moment to perhaps use the off and on here, right? Cool, right? And as you could see, I'm able to offset what I've recorded on the joystick by changing the joystick position as well. So cool, right? We're starting to get somewhere. Let's save this patch. We'll save it on slot B1, right? Oh, what did I do? Did I save it? Is it there? Yeah. So yeah, as soon as it saved, it went back to the other screen. The programming screen. So there's a few different screens for the matrix here. Now one is programming the matrix itself, one is saving and recalling patches, and now another is a sequencer. Well, let's first recall an empty patch here. We're going to create a simple subtractive patch, like kind of a mini-mode sort of a thing, that we'll then use with the step sequencer. Okay, so let's do that. You know, I'm going to leave the sequencer for after I show you the ring modulator and the sample and hold, because I think those are and the noise, just so we see everything that the panel offers before we get into the hidden functions. Alright, so quickly I'm going to make a little voice. We'll use oscillator 1 into the filter. We'll send the filter to the envelope signal. We'll send the envelope signal to the effects, and as well as to outputs 1 and 2, and we'll also send the effects to outputs 1 and 2. This is the kind of patching you'll be doing a lot of if you want to use the effects and have control over the mix. So already we have something here. Now we want the sample and hold routed to this output over here. So we're going to change this switch on the random. From the square wave of oscillator 3, we'll change it to the sample and hold. Okay, now we need to patch the noise into the sample and hold input. Right? That's a mistake I made at first. I kind of assumed that the noise was pre-patched or normalized to the random. Since it says random, it doesn't say sample and hold. But yeah, in order to have it be random, you do have to make the patch to patch the noise into the sample and hold. And then at each clock pulse, the sample and hold would read that noise voltage, which is varying randomly, and hold it for as long as the clock rate is. You can use that to control the pitch of the oscillators. So let's send that sample and hold to pitch of oscillator 1 here, right? So right, so now when I hold the gate here, right, we hear that, you know, familiar R2D2 sort of effect. Sample and hold effect. Let's go back to a reverb here with less time and feedback. This sounds nice. And less level too. Let's make it subtle. Now notice that there's its own clock, right? The random voltage is following its own clock here. The sample and hold rate knob determines that. And that can be cool, but you can also link it to the gate. So that each time you hit a gate, you get a different, see? A different note. So you can send it a clock. Right? Right, so the way to do this is to leave the trapezoid on manual, right? And then we would use the sequencer just to generate a constant rhythmic gate, right? And I wasn't going to show you the sequencer yet, but I might as well, since we need its clock right now. So let's hit Shift and sequence over here, right? Now this little the patch buttons over here, which normally would serve to cycle through the different patches in the memory, now the forward arrow becomes the play. So what we can do is just add one note per step here, make them all the same note for now, right? Because we're not creating a sequence, we're just creating a clock. And there you have it, right? You can have a short decay or a long decay. And now I don't remember how to change the tempo, so I'm going to have a look at my cheat sheet here. Play stop sequence, change note, set sequence length, set notes, set the BPM. Hold Shift and turn the left encoder. So I'll hold Shift and turn the left encoder, and you see a graphic representation of the BPM on. Now, see how it becomes a screen now? And that's how we can set the BPM for the sequencer. Right? You can make it super fast or like a normal tempo. Okay. So now that we have the sequencer engaged, we can apply the trapezoid envelope generator or the LFO to the filter just to make things more fun. Right? So let's hit Shift and sequencer again just to get back to our patching layout over here. And we're going to send triangle of oscillator 3 to filter frequency right there. And note that I've been using just straight connections. I haven't even been attenuating anything. You can always do that when you need to. Right? Just using the left encoder, remember. Use left encoder, you can cycle between 3 different levels of connection. Full, 70%, 30%, and then the fourth would be off. Okay. Doing that already, aren't we? Yep. The filter is responding. Let's make it just low pass filter respond to oscillator 2 as an LFO. Maybe a little more resonance here. Nice. Now we'll remove the sample and hold, right? We can do that by just turning the level all the way down in case you want to like use it again later, or you can unpatch it. Right? We can just unpatch it right here, so it's not patched anymore. And now the sequencer is pre-patched to the oscillators, so we have to just go back to the sequencer, and now we can change the notes. Right, so I can come here, and this gives you notes within the same octave. Now if I press it again, it gives me another octave, see? And this time it's the right encoder that I'm cycling through. Let's turn down so we have a wider range to play with. Octave down, right, is what I'm doing. So here I'm going to make the same note, but 2 octaves high instead of 1. There you go. So basically it gives you 3 octaves of range. Well, we have the gate lengths too, which are cool. The way you do that is by pushing the left encoder while turning the right encoder. So we choose a step here, push left and turn right, and now see, this gives us a long, in fact a legato connection to the next note. Right, let's see this one. Very cool, right? What else can I do with the sequencer? Set sequence length. Hold shift while turning the right encoder. So if I hold shift, I can make the sequencer shorter, see? Right, this is like the last step feature. Very cool. Now if I stop here, I can manually advance the steps by holding the left patch button and turning the left encoder. So clock manual, now you use the play button, which is patch right button, right, to manually advance, and that allows you to choose the note carefully one at a time if you like to do it that way. Alright, so let's go back to clock. Okay, and remember our BPM was you push in shift and left encoder. That's a good one to memorize. Shift and left encoder for the BPM. Let's turn down the filter a little bit. It's getting a little bit annoying. Maybe a little more reverb. And the reverb is digital, but it sounds really nice, honestly. I don't feel the need for it to be an actual spring at all. In fact, this is much more versatile, and it allows for delay to exist as well. Do cool things too by routing the delay to a filter, for example. So let's go back to reverb. Very cool, very nice. Alright, so let's stop the sequence for a bit. Now there are a couple of modulation lanes that you can also program with the sequencer, and that is stepped modulation. And the step modulation signal will come through the joystick outputs here, right? So they're basically, it's like automating the joystick or sequencing the joystick outputs, right? And the way to do that is with the shift and left encoder. So shift left encoder, you push it, right, not turn it. And here we now have, we can draw a kind of modulation sequence here, right? And we can send that anywhere we want, right? This one would be one axis of the joystick, right? And if we do the same again, it gives us another lane, right? And we know which one we're in by the bottom LED here. If P lights up, we're on the second one, and if A lights up, we're on the first one. And it cycles through the 3 pages. So this is the second modulation sequence channel. We'll leave it like that. Shift left encoder. So main sequence page, first modulation sequence page, second modulation sequence page, right? And now we can go back with shift sequence here. We can go back to the actual patch itself and patch things to the joystick here, so that some certain parameters can be affected by these sequences that we just did. How about for the filter? Instead of the LFO, we now use one of these channels for the filter frequency, right? And what could be another? Oscillator shape could be another. It'll be kind of subtle because it is a subtle parameter, but we can do that and it'll be interesting. Now let's play the sequence again. Uh-oh. Oh, good, I didn't lose the patch. It looks like it's still there. Yeah, you see, be careful. You can't just hit play when you're not in this sequence page, because that becomes a patch forward or backward button, right? So we have to actually hit shift sequence here, and yeah, we lost our sequence because we hadn't saved it. So let's create a new sequence. This is nice. Let's change the gate length of a few of these steps. How was that again? To set notes gate length left, push left encoder and turn right encoder. And let's go. Very cool. Now let's go back to the main screen and see here we have the joystick. I think the joystick is, we just need to clear it. Oh yeah, this is that other patch where the joystick is affecting the pitches. We don't want that. We want the joystick to affect filter frequency and oscillator shape. Now we can go back to the sequencer and go back to one of those step modulations, so shift and left encoder, shift left encoder, and now we can play around with the modulation sequencer. Cool. The other one. I have a feeling this is going somewhere else. Oscillator shape, filter frequency. No, that's correct. And of course, the joystick acts as an offset for these voltages coming through the sequencer, as well as these knobs right here. Right, they can attenuate completely our modulation sequence. Cool. Let's enable the shaping and filtering here in more interesting ways, more resonance here, a little more reverb. Oh, cool. Let's save this patch. Save. We'll save it on slot 1C. Now we're on the matrix, right? We're not on the sequence page. If I use the patch buttons, they'll cycle through our different. So this is the joystick one, and this is the first one that we did just to hear the oscillators through the filter. Remember? So this is cool too. That very quickly, you can organize your performance in such a way that your patches are in order that you need them to be, and you can just that simply move forward or backward through your recorded patches. Right, let's go back to recall, and we'll recall a new blank sequence here again. Okay, all right, so let's have a look at the manual and see what can we talk. Oh, let's talk about the ring modulator real quick. So the ring modulator has one fixed source and one selectable source. Actually, both are selectable, but one is selectable via the matrix, the other is selectable via the switch over here, right? So I can send my sine wave from oscillator 1 to ring mod A over here, right? And source B, I can choose it to be any of the external inputs. It could be the noise, it could be the filter in self-oscillation. In fact, that might work well. Let's put the filter in full resonance, and we'll choose that, which is the filter. And now we can route our ring mod to the effects, and then send effects and ring mod to the outputs. Okay. And now we have the pitch control of the low pass filter and oscillator 1 pitch control doing our ring mod here. Won't it be fun to assign the joystick to these pitches? So we'll send one axis of the joystick to oscillator frequency 1 and the other to filter frequency, right? And now we'll record. We'll record some movement. There you go. That movement got recorded there. Right, and I can control the width of that modulation, the center of my pitches, the octave here for one of the oscillators. I can turn up the sine wave level here and the filter level, and then we'll turn down our outputs. This is too loud, and I can still use the joystick again, and I can also use the sequencer if I want, right? So this is the ring mod. Now if I change here to noise, for example, now our noise is source B for the ring modulator, right? That's kind of a cool, and the noise has a tone control as well. In fact, now that we've looked at the ring modulator, why don't we have a look at the noise? So let's save this patch, and we'll recall another empty one. And here I just want to hear the noise real quick, so we'll send it to output channel 1. Right. Let's center that so we're here in the middle. And here's the level. But I just realized I need to mute my DAW here. There we go. Okay. So yeah, we have the noise level. So we have an individual volume control for the noise, and there's noise tone, which is just a filter, right? So you can get very bassy. It's like a tilt filter. You can get this very bassy noise, which can be super cool, especially if you send it through a resonant filter. Or you can make it more and more high-pitched, and it cuts some of that bass off too, see? So that's why it's tilt filter. Emphasizes lows on one end, emphasizes highs, and de-emphasizes lows on the other end, right? Let's route that through the filter and listen. And maybe the filter through effects. I'm loving the effects on this thing, so I'm always going to use them. And now we can have the effects left and right, as well as our filter left and right. We'll turn down the resonance now because we don't want it to be self-oscillating, right? And we can turn our pan left and right and volumes on the outputs here to get the stereo sound. And now we can assign the joystick to control the filter, right? So let's do that. Just one axis of the joystick will do for that. Filter frequency, right? And now we can create like winds, polar winds and oceans and things. Let's just make kind of a beach ambience. So I'm going to record some motion here on the joystick. There it is. Oh yeah, to clear the joystick memory, you double press rec clear here. And I can also do effects automation. I can hold the record while moving the time knob. So let's turn up the effects here. Let's see what the effect the time knob has. It's interesting. It definitely does something. So let's record some motion there. Right, so the same way as we use for the joystick, we can do it for the time knob on the effects. And there it is. Now can I also record joystick motion on top of that? I have a feeling that if I do it, it's going to overwrite our time thing. Looks like it didn't. I still kind of hear that time parameter. So cool. So this is like a tsunami happening here. Crazy, crazy noises. Now we can turn down our noise tone and hear what that does. Oh, cool. So now it's super bassy. It's like we're using a microphone with no windscreen to pick up the wind noise right now. Very rumbly. So this is great noise source right here. Very cool. Alright, I'm going to save this patch too. Alright, let's recall another one with nothing in it. And let's have a look at the manual to see what could be our next subject matter. Well, there's sync on the oscillators. I didn't show you any sync, but for that maybe it'll be cool to connect a keyboard and we can do some more conventional kind of synth sounds, keyboard controlled synth sounds, right? I just moved up my camera to pick up the keyboard as well as the synth, and we're gonna connect output 1, MIDI output 1 from my KeyStep Pro, trusty old KeyStep Pro, into the MIDI input of Syntrx II, right? And this will, it's automatic. You don't have to route it with the matrix at all. The gate of the keyboard will automatically trigger the gate on our synth. And yeah, again, let's create a little patch here. So we'll take Oscillator 2 to the filter, Oscillator 1 sine wave to the filter, and we'll shape that sine wave weird. We'll send the filter to the trapezoid envelope signal, Actually, that's trapezoid. We want to filter, right? And then we want that envelope signal to go to effects as well as our outputs, and we want the effects to the outputs as well, right? And already when I hit the keyboard, you see that the trapezoid lights up, right? So we know we're in the right MIDI channel. I think it's just channel 1. I'm sure there's a way to configure that. We'll look at that a little later. It looks like it started raining outside. I hope it doesn't bother you too much, the noise. Okay, so now we have 2 oscillators going to the filter. The filter going into the envelope signal. Envelope signal going to output and to effects. Alright, so this is kind of like a normal subtractive type of patch, right? Let's tune it. Too much effects. As you can see, the oscillators are in tune and stable, which is one of the differences between this synth and the originals it's inspired by. Those were very chaotic, or are very chaotic, and unpredictable, usually. So here's shape, it's the sine. We're only going to use a little bit of the saw here, and a little bit of that cool shape sine. And now we can sync them. So now Oscillator 2 is controlled by Oscillator 1, see? Well, let's go to square waves for this. We'll add the square wave to the filter here. Really hear that Oscillator Sync when I modulate the frequency of Oscillator 2, which is synced to Oscillator 1. Right? So I start getting these kinds of sounds, which are cool. Almost like chiptune-y. There you go, Oscillator Sync. Very nice, right? And I can modulate Oscillator 2 now, and we'll hear the automated sync. So why not use Oscillator 3 triangle wave to affect Oscillator 2 frequency. And there we have it. Cool. All right, now I'm finding that I want it to go lower. Now let's say you want the pitches to go lower. Right now I have my octaves all the way down on both the synth and the controller. So what I can do is add one of my joystick axes to control the pitches of both oscillators. And now suddenly I can offset the whole synth way down. I can even come back some octaves on my controller. So even when you think you found a shortcoming of the synth, there's always a workaround when you think about it. Very cool. Now the Oscillator 3 has a key follow option, like in the button here, in the switch. So right now I have it free, but if I put it in key follow, my lower notes will have a slower LFO, which will get faster as I move up the keyboard, right? And you can also kind of put it in audio rate and it becomes FM, right? If I take off the key follow, then you get like this constant frequency FM. If I put in key follow, so now we have the audio rate affecting the Oscillator 2, which is synced by Oscillator 1. Very interesting sounds. Right, and I can even record a sequence here, maybe. Let's put this one back slow. Now I can send an inverted version. Of the LFO to control the filter if I wanted to. And the way to do that would be to externally patch the scope output. So I'd route LFO to the scope output, take a cable from the scope output into input 2, which has an invert option, right? And put it in line, turn up the level, put it on invert, and then route that input 2 to affect the filter cutoff. Right? Or you can do that with any CV source, external CV source. You can send to either one of these inputs. Both of them respond to CV as well as audio. Right? Alright, so that keyboard control, key follow for the Oscillator 3, and syncing, Oscillator syncing. So let's see, what else am I missing? We haven't really used the trapezoid output of the envelope very much. We've only been using it for its built-in VCA, right, and controlling that VCA. But know that you can, for example, send the trapezoid output to the filter and have your filter open along with the amplitude, right? Or not even use the trapezoid at all. So let me save this, and we'll do that. We'll do a patch where we use the trapezoid for the filter rather than for a VCA, and the filter will be kind of our VCA when we do that. Let's save this patch, and we'll recall an empty one. And now I'll send a square wave from Oscillator 1 to the filter, the trapezoid to affect the filter frequency. And we want the filter now will go directly to the output, right? And we'll turn it down. Let's send that joystick to to the filter frequency too, right, just to get bass here, right? Or we can turn the low pass filter to where we don't hear anything anymore. So only sub audio is passing. And now the trapezoid is opening that up. So we're basically using the filter as our VCA, and then you can get these funny kind of sounds, right? Where the filter is reflecting the envelope. And right here you have the trapezoid volume control, which right now becomes the width of modulation for the filter, right? And of course, right now we have the filter in band pass. We can have it in low pass as well, or just high pass. So low pass, bring that trapezoid knob a little down, and you can get this kind of sound. Well, when we send that filter to the effects as well, and the effects to our outputs. How about a slight vibrato, right? We can send Oscillator 3 to the pitch of Oscillator 1 and just turn down that level. And have kind of a subtle vibrato to make this even funnier sounding. And the joystick becomes like our pitch modulation, like extreme pitch modulation. Here's our sequence. Right, so now we're foregoing the use of the trapezoid built-in VCA, so that signal doesn't do anything here, just so we can use the trapezoid envelope signal for the filter. Because if we use it for the signal as well, then when the filter is low, the volume will be low too. We don't always want that. This is already pretty cool. Alright. Let's see what else. Output filter. I haven't mentioned the output filters. So these are just simple tilt EQs, basic tone controls for the two outputs, right? So these are apart from the resonant filter, you have a little bit of tone control as well with these guys. Both output channels feature an output filter that is essentially tone control. If the control is at 5 on the dial, it's flat. So you can just leave them here and it won't be affecting anything. Output amplifiers, we've already talked about. It's basically our level and panning control for the two outputs. We've been using it mostly in stereo with panning left and right, even though most of the patches we're doing are actually mono patches. The way to do a stereo patch maybe would be, for example, we can have the filter only go to one side, and we can send the sine wave to the envelope signal, and then the envelope signal to the second output. Right? So now we have different sound on left and right. That's one way to do it. I'm sure you can think of many other ways. Okay, the inputs. We talked a little bit about the inputs. Like this one has a make or line, and it can invert the signals. They work with CV as well as audio, and that the first one has an envelope follower, right? And this is the envelope follower level, right? And there's the envelope follower present right here, so you can use it. For example, I can plug in a bass guitar and use the envelope follower to open up a filter. So I process the bass guitar with that filter. So why don't I do that? Let me pull out one of my basses, and we'll play around with some envelope filtering using input 1. Okay, give me a minute. So this is my GNL bass. I am a bass player, by the way, in case you didn't know. Synths are very important for what I do as a composer and sound designer, sound engineer. But my main instrument has always been the bass, even though lately I've been practicing the drums a lot more, focusing on the drums. Still, you know, I'm a bass player at heart. So let's turn that up. So already very cool as I play the bass. I have the 2 gate engaged, the button here. I'm generating a gate that triggers the whole synth. Right? But let's save this patch and recall an empty one. And what we're going to do now is we're going to route the input where the bass is plugged into. We're going to route that to the filter. And we're going to route the filter right back out to the outputs. Filter, right? And now we're going to send the envelope follower to control the filter frequency. Maybe a little bit more resonance. And there we go. Actually, play this. Very cool. Oh, it's out of tune. Cool, right? I can also use the trapezoid instead, right? Since I'm triggering the trapezoid, that would be a different way to do it. So let's do that. Well, first let's route this filter to the effects. Just get a little bit of effects in there. Cool. Now let's try the trapezoid idea. Instead of the envelope follower controlling the filter directly, we'll use the trapezoid to control the filter frequency, and we'll trigger the trapezoid with the envelope. And we just need a longer decay now. And you bring the threshold down, level up. cool. It's alright, but I think I like the direct control better. So we'll go back to envelope follower. Delay. Drive it a little bit, right? Turn that level up. A little distortion here. Very, very cool. I feel like I'm redeeming myself from the live stream I did with Geertz where I didn't know the synth well enough. Super embarrassing. Be live on air with, you know, the visionary behind the instrument and not knowing the stuff. So this is my video to redeem myself. So I'm trying to do things correctly and accurately and give you good information. Let me have a look at my cheat sheet to see if there's anything worth mentioning that I haven't. Well, there's I showed you how to navigate with the joystick, right? Let's save this one and we'll recall an empty one. And I showed you that if you hold shift in the joystick you can navigate, right? Well, to draw you hold shift and the right encoder and you kind of like draw on the matrix, see? And I just like completely created a patch just from drawing like an Etch-a-Sketch on the matrix, right? And of course it's a pretty random patch. If you want to erase on the matrix with the joystick, you hold shift plus rec clear. So shift plus rec clear and move it around. So now we're wherever our cursor, so to speak, goes, it's actually erasing connections rather than making them. These are more experimental and improvisational ways to patch this instrument, right? If I want to erase a patch, push Shift, Save, and right encoder together. Shift, Save, and right encoder. So it's all these three. And now it gives me delete 9. Do I want to delete it? There's an X here and a check here. The check means yes, the X means no. I click on the check and I've erased that patch. If I want to audition a connection rather than make it, I can just hold shift. And when I press the encoder, I'm listening to what it does. If that connection is made, let go and it's not anymore. If I then like it, I can push the encoder and the connection stays. You can create a random patch. This is fun. You just hold shift and the right patch button right there. And of course, if you like, this one is even controllable with the joystick. Very experimental and weird. I can study what happened here if I want to learn like to do something similar, but I can also just save it in the slot and recall another empty one and then do it again. Listen, that's like a drum machine. I kind of like this too. Save it. Alright, recall another empty one and another random patch. Wow, these are better than I can do by like actually intentionally creating patches. These are great. I'm saving this too. Recall, and here's another random patch. Wow, this is loud. Let's turn this down a bit. And it also responds to the joystick. And of course, if you change, like this is this, if you change parameters on it, you know, oscillator frequencies, filter frequencies and whatnot, and you will get different sounds as well, because the patch memory is only for the matrix connections, not for any of the knob positions. It does also save the sequences that you create, and they're very cool. Here's another random one. And if I hold shift and encoder, I can like draw around on the patch too, right? So on top of the randomicity of the patch itself, I can randomize it further by just drawing all over it, and shift rect clear to erase connections and make it less dense, sparser, right? Play direction. Play direction is interesting. Let's recall, I don't remember which one of these patches was our sequence. Let's see. We'll just go to the sequencer. Yeah, this one has one. Right? So this is the sequence right here. Now you can set the play direction if you hold the left patch button and turn the right encoder. So I turn the right encoder, and now it's going backwards. Right, that's the one thing that I had forgotten to mention about the sequencer. And now it's ping pong, going back and forth. So yeah. So the sequencer and random. So you have forward, backward, backwards and forwards, and random options for the sequencer here. Very cool. So this is the random one. Alright, let's stop the sequencer and get out of it. Okay. Turn off the level here. And yeah, because I was re-triggering the gate with itself by sending our output to the scope, which is normalized to the input of to the external input. Okay. Let's see, we've talked about play direction, resetting the sequence. Oh, right, hold shift and press play. So that's, oh, hold on. Let's go back to the sequencer. So if I hold shift and press play, I'll reset the sequencer, see? And by reset, I don't mean like erase it or anything. I mean just go back to 1. Right? Cool. Now, step modulation, we did talk about that. Reset VCO pitch on stop. Shift recall on sequence. So yeah, so if we are on sequence, if I do shift recall, that's gonna reset the pitch of the oscillators. Now, if I'm back in the matrix view, and let's say I just want to turn all the LEDs off for a while. I don't know, maybe they're bothering me, it's dark. The way to do that is shift recall, right? They're empty, but they're still, the patch is still there, right? It's still patched. And if I turn anything or do anything with the matrix, it lights back up. The MIDI implementation is pretty simple. You select the MIDI channel in which the Syntrx receives MIDI note on, gate, pitch wheel, modulation wheel. The modulation wheel is assigned to the VCF cutoff already, which is nice. And there's 2 configurable CC messages and note velocity message. So velocity is also assigned to the VCF cutoff. And you can assign CC messages to the joystick outputs. They're added to the joystick X and Y control voltages. And that's in the configuration settings section of the manual. Here's all the configuration settings. There's patch relevant settings, global settings, patch randomization settings, MIDI channel, sequencer clock source, pitch bend range, MIDI clock division, MIDI note offset. There's a whole bunch of cool things you can do. Patch view mode, MIDI DAC, manual calibration, matrix dimming, firmware version indication, factory reset. Honestly, I think these things are really boring for me to just start demonstrating them. These are things that you should just look at the physical manual whenever you need to use any of these functions. As far as everything else, I think I've covered it. Hope you liked this video. I hope you're enjoying your Syntrx II. It's a jewel. It's right now sits in a very prominent spot in my studio and gets used a lot because I really enjoy it. And I like the fact that I can create something and save it, at least the routing. If you have any questions or comments, please go ahead and ask below or comment below. Give this video a thumbs up, a like. See you soon. Stay noisy.